Vladimir, can you tell us when did you start studying cold nuclear fusion? And can you dwell a little bit upon the subject? Well, I must say that historically, it turned out that a book by Vladimir Vernadsky, our famous academic and founder of geochemistry, was published in 1965. And the first chapter of the book was about the geochemical evolution of chemical elements. Vernadsky have created a genetic mineralogy, in other words, mineral evolution. He knew perfectly well that if minerals undergo evolution, then there must be an evolution in chemical elements. And so at that time, Vernadsky stated his third assumption that chemical elements are evolving over the course of history of the Earth. That is to say, the decay is present and the process is natural, but we did not observe it with an aided eye back then, meaning that it was still hard to understand and explain it. But as a great geochemist, he observed this process both in the history of the Earth and in the history of cosmochemistry. And so when I was young, it really gripped me. And since a very young age, I was really interested in nuclear physics. It was all I cared for. And so for some reason, deep inside, I felt that this is what I should be doing. And so it wasn't a question of choice for me, really. It was a no-brainer. I was certain about what I was going to do. Back then, nuclear physics were very popular. In 1961, if you remember, a famous movie came out. It's called 9 Days in 1 Year. It's about a Soviet nuclear physicist. I must say that this movie must have influenced me quite a bit. I was really fascinated by it. Great actors. Amazing performances. The romance of that vividly scientific piece of work written by a nuclear physicist also played a certain role. So all this put together laid the groundwork for building my future scientific and geological career. And so I decided that I was going to study mineral deposit search. I was carried away by geochemistry and the genesis of minerals. And the very idea of transmutation was hatched and developed in parallel. I should note that some of those large physical discoveries that played an important role in the shaping of my beliefs. For example, in 1979, a whole series of important works in the history of, let me see if I remember right, on a theory of the quasi-crystalline structure of the atomic nucleus were published. In 1982, a series of papers on nuclear molecules were published. And in 1984, a fundamental discovery was made both in Russia and in England. A cluster radioactive decay of chemical elements was discovered. And those few events that occurred in nuclear physics have completely convinced me that this process takes place in geochemistry as well as in geology. In our childhood, we were taught that only alpha particles decay. However, physicists at the Kurchatov Institute in Dubna and in England showed us exactly the opposite. We learned that heavy nuclei like transuranium elements, uranium, thorium, can emit nuclear clusters such as carbon, nitrogen, oxygen, silicon, and magnesium. And if you look at it from the geochemical perspective, all of them are light elements that form the crust of the Earth. This provides a whole chain of origin of rocks. And so when the decay chain became clear, I began collecting specifically geochemical and mineralogical materials of ore minerals. And so that allowed to demonstrate that not only a radioactive cluster decay exists, but there's also a dissociation of heavy and super heavy nuclei with the mass of up to 100 Z per multiple division. So what is dissociation or transmutation? It is the decay of nuclei in certain non-rigid conditions when a nucleus is divided into almost equal parts. It is very interesting that a large number of valuable minerals have exactly the same coupled chemical elements of the so-called isomorphous replacement of a certain element by another element. And it turned out that this is not just a replacement process, but that it actually allows for emergence of new atomic nuclei, and that it yields an isomorphic mixture. And sometimes those minerals can be found in rocks and in minerals themselves. So would you say that the whole Mendeleev's periodic table emerged as a result of transmutation? Well, the thing about it is that not necessarily. It originated from initial proto-nuclear aggregations. And the first nucleus in the geochemical terms was, and still remains, uranium. It turned out so that the 4 uranium mass numbers provide a whole variety of chemical elements that form the crust of the Earth. And if you take a closer look at the ratio of atomic nuclei, which are contained in the 4 atomic masses of uranium, and the chemical composition of the ultrabasite rocks that give the rise to the entire geochemical evolution of the Earth, those are actually the same in terms of the atomic number and in the ratio percentage. This, in fact, initiates transformation of heavy, super heavy, and hyper heavy atomic nuclei, which are created as a stellar matter, and then they evolve, and so that's how the fission process occurs. Fission can occur according to the masses as 1:1, 1:2, 1:4, and the golden section is one option. I call it counter-dust. Chemical elements represent a counter set, which means they undergo a fission into 2 equal parts. And so, in nature, the simplest symmetry, the division of matter, is 1 into 2. And more often, isomorphic elements that can be found in minerals and rocks are formed by this particular method. With ore elements, this occurs in a slightly different way. Those are trace elements. For example, the process of nuclear dissociation results in light elements emission, but depending on the geological conditions, the process of dissociation and cluster decay goes through several stages. And if there's a closed-loop system, resembling a sort of mini nuclear boiler, then the nuclear dissociation process runs until the end and up to the lightest elements. There are also open systems, like rift systems, or a flood basalt. That is when basaltic lavas come pouring out in a natural way. So, once geologically launched, whether it be on the moon or on the Earth, if the system is open, the process is constantly running in the same pattern. And if the system is closed, for example, with the Earth's crust or the upper mantle, then the substance that is coming from the depth of the Earth is, metaphorically speaking, pushing right against this lithological roof. And so then, even more complicated plum upwelling systems occur. Substances are joining in on the fluid levels, and those are called lithospheric fumaroles. They enter the surface of the gas state of matter. Then the so-called lithostatic pressure changes, which causes the nuclei and proton-nuclei split. And again, that all depends on conditions. They reach a certain level, and depending on how far they go, different minerals emerge. For the most part, those are, well, just to name a few, those are iron, nickel, cobalt. They belong to one group of metals that undergoes a certain process. Those can be rare minerals such as carbonatites. This is a rare, complicated system, and it's explosive in nature as it occurs inside the Earth. And when the process of its nuclear dissociation, decay, can't reach the end, it doesn't have a chance. And a large number of rare minerals are produced: uranium, thorium, and also deposits of lighter elements. The splitting process divides in two stages. Some are trace elements, others are lighter elements, for example, phosphorus, zinc, cerium, strontium. So basically a whole variety of light and rare elements. So that's one option. And another peculiar thing about this isolated system is that diamonds are formed in kimberlites. And kimberlite is a rock of the same origin which did not break through the surface of the Earth, but rather exploded in the uppermost part of the Earth's crust, forming a so-called kimberlite pipes. And the diamonds are formed in the kimberlite pipes. They do not appear as a result of a physiochemical process, but rather due to the nuclear chemical transmutational explosion, which follows the titanium-magnesium-carbon pattern. And so dissociation of transmutation occurs. Molybdenum, 2 titanium, 4 magnesium, and 8 carbon are coming from below, and the carbon explodes, and that gives rise to a diamond. If the kimberlite pipe is large, and the process in there goes on and free carbon is released, the diamond begins to grow according to physiochemical laws, forming into a fully grown, valuable diamond. So diamonds usually have 2 generations. A diamond and a diamond, so to say. There's always a seed which later gets carbonized. Any crystal always has a primary seed. Kimberlite pipes have this unique way of growing diamonds within 2 growth stages. This process can be well observed in science and production industry and in the genesis of diamonds. Can transmutation occur in live organisms? Yes. There's a lot of scientific proof to that. The first works on transmutation in living organisms belong to the French scientist Louis Cuvrard, who devoted his whole life to this subject, and he actually managed to demonstrate a lot of such reactions in living organisms, like calcium appearance in microorganisms and emergence of silicon in the diatoms, where silicon is formed as a result of combustion of carbon and oxygen. Well, Cuvrard was carrying out experiments on workers in Sahara. And perhaps you know that workers in hot production units drink salt water. And why is that? Well, for the sodium intake, of course. And the thing about sodium is that when it enters the body, it quickly combines with oxygen, and this process gives the rise to the energy that cools in the body, producing potassium. So that was certainly one of his unique observations. He also studied suntan stones. Iron and manganese they consisted of were constantly changing, which sort of also a form of biological transmutation, if you will. Also in microorganisms, boulders and rocks, such transmutations occur under the influence of the solar radiation. What experiments have you carried out personally? I've spent many years experimenting with heavy metals. Some of my first experiments were related to the body silicon, which is a biological transmutation. And as for phosphorus, there's a very interesting story. Once there was a very famous Russian academic, Vasily Williams. He developed a so-called grass rotation system. The principle was that for 3 to 4 years, the land was supposed to be covered completely in clover. So over the course of that period, the soil was supposed to get richer with phosphorus and nitrogen, the main biogenic chemical elements. The idea behind it was that cereals enriched the soil with phosphorus, because cereals contain a large amount of silicon. If we assume that plants fractionate, or in other words, split isotopes of silicon, then one of the isotopes easily turns to phosphorus. And then when the growing season ends, plants emit phosphorus into the soil, thereby enriching it with this element. A clover is a nitrogen fertilizer. Its root system enriches the soil with nitrogen. These were the first experiments carried out to study this reaction. Right. And so the second experiment was carried out with diatoms. And I wrote my first work on biological transmutation. The thing is, everyone believed, and still believes, that diatoms build their silica skeleton using silicon dissolved in the seawater. And so I collected all the data on this topic, and it turned out that it was 10 to the power -7 of silicon in the seawater. And diatoms live only for a few weeks. They're not physically able to process such amounts of silicon to create the skeleton. Okay, but you might as well say that there are admixtures of clay fraction. But it's not possible. The clay fraction can go through the membrane holes. It can be absorbed. And so I started making comparisons. It turned out that during the flowering of diatoms, CO2 as a gas component disappears from the oceanic upper layer, and phosphorus remains. It became clear to me that diatoms absorb CO2. Some oxygen goes for nutrition, photosynthesis, and other CO2 combusts and yields silicon. And so this silicon is used to build the diatom skeleton. The experiment was carried out, and an article was written. It was back in 1975. Of course, nothing was published, but I managed to finish my work, however. And weirdly enough, during that period of time, a very good article was published by Maria Glazovskaya and a professor, soil scientist Boris Polinov, also a very popular biochemist. And so she wrote almost the same work, but only on phosphorus in soils. And so then she published it, and if I remember correctly, this was one of the first works on transmutation published in the Soviet Union. But of course she took her bit of suffering for that, as you can probably imagine, that poor thing. I knew her well, actually. We used to talk a lot. And so then there was a long period of collecting materials, theoretical generalizations, scientific physical discoveries, and in the late 80s and early 90s, and almost up until 2005, I finally started conducting cold fusion experiments with heavy metals, taking lead and its alloys as a basis. So by that year, many things came very clear to me. A structure of nucleus, a method of impact on the substance in order to demonstrate how the orogenesis runs and occurs, basically. And so I figured out that chemical elements are not brought from out of nowhere, but rather that they're nothing else but a deep substance that has undergone the evolutionary process. Then an installation was created which remotely resembled the lithospheric shell of the Earth. In particular, the magnetic field into which the melt of those elements was poured, which underwent an impulse action, which is with an amperage of 7 to 10 kiloamperes, and with a frequency of 450 kilohertz, and 1000 volts. The results were absolutely amazing. They were stunning. 3 very important discoveries were made. First of all, we managed to synthesize natural minerals. Can you imagine that? We managed to get cuprous-stibite. It's a rather rare mineral. It was discovered in Greenland, and then it was discovered in the southern part of Ural. And it's cuprum, stibum, plumbum, plus admixtures. And when we conducted analysis of our melts and studied the structure, it turned out to be the cuprous-stibite by the composition of isomorphic admixtures and the crystal structure. We sent all the elements we obtained for isotopic analysis, and it turned out that there were no isotopic processes, but instead a redistribution took place, while the isotopic ratio the atom possessed remained unchanged. And secondly, the whole active element was targeted by sensing devices to detect neutrons, alpha particles, gamma rays, to see if the nuclear process occurred. And it turned out there was none. There was practically no release of neutrons. And this indicates that a cluster reaction took place. Clusters of oxygen, carbon, nitrogen, silicon, and magnesium were emitting. And it turned out that, and nuclear physicists know this perfectly well, tearing one nucleon from a cluster takes a huge amount of energy, and so it was much easier to tear it apart and pull a cluster out when there are only 50 to 20 kFe in this process, which is much lower. So this was also a very important discovery, and we weren't the only ones who came up with it. It was later confirmed that in other laboratories that the cluster decay and the cluster transformation of nuclear dissociation produce less energy, which means they occur at low energy levels. And so the third thing that these experiments showed was that when carrying out ionization by impulse, the ionization of the atomic nucleus takes place. A part of the electronic shell is blown off for a moment, and when it leaves the nucleus begins to divide more actively. It was later confirmed that by using many heavy elements, for example, rhenium, when the electronic shell was blown off by a discharge, the half-life of rhenium was reduced by 6 exponent. It was confirmed that the atomic nucleus and the electron shell are very tightly energetically connected. There's a huge difference in numbers, and somehow nobody seemed to have paid attention to it before. It was believed that it can be observed separately, but there was no way of doing that. And so it turned out that this can be applied for, biological systems. And so the first person who ever drew attention to this was Kapustinski. He published a very interesting research in 1958, showing that the chemical nature of the substance ends within the Earth's depths deeper than 700 kilometers. And so a chemical element and its nucleus should be observed as a single system, since there are no distinct chemical properties. These properties occur only when the lithostatic pressure changes. Then, the chemical element acquires independence as an atom. So its nucleus, its electronic shell, its chemical compound. And so all of that was shown in those experiments. And so later on, when the series of experiments were finished, I started looking for those experimental paths that were sort of, closer to nature. That is, impact methods through plasma. A low-energy plasma is exactly what leads to a non-equilibrium state of a chemical substance, in which stable processes and reactions of nuclear dissociations can be expected. And so, another important conclusion that we made, and that is the one I described in my book, is that on the basis of numerous geochemical studies performed by Alexander Fersman, who created a geochemical star scheme. So groups of chemical elements are always interconnected, and on the basis of these experiments and calculations, we managed to show that the Mendeleev periodic table should not be considered from hydrogen to uranium, but another way around, through the process of cluster decay of nuclear dissociation, and above all, geochemical data absolutely clearly yielded thousands of analyses that show that the interacting elements are genetically connected through certain groups of elements. It exists as a search sign in geochemistry and geology. It's clear that if we have a certain type of deposit, then there are certain types of chemical elements, and this genetic type yields a subsequent, strictly defined type of elements. And that's why we have a geochemical basis, the ultrabasite one, let's say, medium rocks of carbonatites, kimberlites, up to granitoids, granites, and so all of that is very strictly interconnected. Is it difficult to speak and publish the results of your work when most scientists deny transmutation as a phenomenon? Well, you see, the thing is, I wrote all of my transmutation researches for scientific journals, and that is because I was not allowed to publish in peer-reviewed journals. They sort of have their own way there. However, this can be published in the hypothesis/discussion section. And since 1999, a number of works on the subject appeared. Many physicists who studied the nucleus are familiar with it. And I know quite a lot of nuclear physicists at Kurchatov Institute and in Dubna who perfectly understand these processes and don't complain about it because they have realized the common approaches to these processes. And so those publications have managed to compile were academic. They were aimed at showing the process of this phenomenon as the one occurring naturally. There's one peculiarity, and it's common for many sciences. At some point, everyone reaches sort of researcher's block. And it's a point when all the existing hypotheses are exhausted and new ones haven't been established. So these days, all physical, chemical patterns and the process of orogenesis no longer work. It's the right time to look for a new approach, you see? And we must come to the point when we finally start to assume that a chemical element is not a solid brick, but rather a process. The process which begins in a stellar matter, emerging from a stellar matter all the way to the Earth's crust. A chemical element evolves under the geotectonic conditions it finds itself in. And so it's crucial to comprehend the idea that a chemical element is not a brick, but a process, and that it can transform. Since 1700, we've been taught in atomism that an atom is inseparable. There always was someone who tried to prove this idea wrong. Alchemists were more correct in that regard. They had another task, but they weren't denying such outcomes. But then they decided to let it go somehow. Though it was a different time back then. We have to mention some of our scientists, such as Kurchatov, who managed to send an expedition to Kamchatka to find out where the volcano energy comes from. Kurchatov conducted all the experiments himself, but those experiments didn't progress any further. There are scientists who try to take it to the next level, and nowadays there's a group at Kurchatov Institute who study this phenomena rather successfully. And also similar processes have been studied at the PN Lebedev Physical Institute. Their main focus happens to be the transmutation phenomenon. Their approach is slightly different, you may say. It's purely physical, but they have already achieved some obvious results. So, one small step at a time, you should have patience, and one day it'll be a huge step for mankind. But why, when somebody brings up the cold nuclear fusion, some scientists and Philistines deny it as a phenomenon, mentioning the Coulomb barrier? Oh yes, I know that one. The Coulomb barrier is all about the impossibility to bring two nuclear cores together. And the point is that our nuclear physicists and all the other physicists still live and operate on the Newtonian principle, strength against strength, whereas the Coulomb barrier is easy to overcome using a so-called resonance isomorphic phenomenon, resonance synchronization. A friend of mine, nuclear physicist Vladimir Krivitsky, developed a remarkably important approach. So this good friend of mine developed and showed the way in which, better yet, he developed a synchronization system for nuclear physics. And so according to Huygens' principle, we can hang pendulums to a fixed base and then start swinging them in the opposite directions, making them keep on swinging. But if we take a rope instead of the fixed base and we'll repeat the exercise then, so after a while, all of the pendulums will start swinging in the same direction. And that's the principle of synchronization. The first one who drew attention to this principle was the famous German physicist Schrödinger. He described the experience for elementary particles and Van Gogh for atomic nuclei. When he realized that my experiments were correct, his synchronization worked perfectly well. So the point is that when the synchronization process occurs, there is no need to overcome the column barrier, because the column permeation occurs. So nuclear cluster gets through the barrier. They can't go too far, so a nuclear molecule forms, and so it comes to be another element. There are two different elements, a parent element and a child element, and this is the basis for cluster decay and nuclear dissociation. And many people are familiar with the barrier. Maybe they've taken classes and they know about the energy needed. There's a rather complicated phenomenon. When first nuclear explosions took place, the energy released from those explosions made people go crazy and brought minds of many scientists into a sort of haze. They started believing that we can overcome the barrier only by taking that trade. But the fact of the matter is that the nature is wiser, it's smarter, and that it can adapt. Now take biological transmutations, for example. For 3 billion years, first living organisms on our planet have been evolving in order to be able to create their own habitat. And the habitat is all about mobile biogenic elements used as a whole. And so living organisms has mastered this mechanism. The evolution process started running at a faster pace. And so my point is that there's no possible combination of elements ever existed. And it weren't enough to evolve, and a special environment should be created in order to initiate the evolution process. Do you think that transmutation can be somehow used in the modern world? Well, frankly, in the modern world, there's still much more to be done regarding this issue. First of all, we have to accept the very existence of the biological transmutation and help any living organism, be it a human or an animal, just like in the primitive grass rotation system I mentioned earlier. I mean, we should introduce into the diet those components that lead to certain transmutation, and we must help the organisms to avoid a shortage of any elements. We must understand that there were many lifeless areas on Earth, and so that's why living organisms were forced to develop the ability to transmute in order to utilize the empty zones. So basically that's the one way. Though technologically, of course, there's so much more to be done. First of all, it's the ecology, energy resources. And if we learn how to obtain certain isotopes from several components and chemical elements by selecting combinations through the plasma and laser impact, results can be applied in electronics, superpower magnets, and, etc. We have a lot of work ahead of us, frankly. Suppose the lead is the initial element, and it's perfect to work with. It's non-radioactive, it's easy to impact, it has a low melting point, it interacts with many chemical elements, and these interactions can be used to obtain certain combinations for platinum metals, osmium, iridium, or even obtain rare elements such as hafnium or zirconium. So there are loads. And I'm talking about the kind of elements that are of a high demand from the technological perspective. But the problem is that those are very rare, and transmutation can serve as the profound source of such elements, because you don't need to break through tons of rocks to extract them, you see? And our approach is a lot cheaper, and obviously it's a lot more effective. Basically, it's the future. Modern technology already allows us to apply this method. We must concentrate on one major thing. We must learn how to implement this technology more efficiently in order to be able to obtain a certain chemical element, or, more importantly, a certain isotope. For example, in medicine, some isotopes are of great importance. Certain isotopes' delivery is crucial to an affected cancer cell. Some isotopes can be used to heal wounds or to cure other illnesses related to a shortage of particular isotopes. Molybdenum or other isotopes of active metal zone and organic enzymes. So the basis for the energy hub is the metal. And so that's where all isotopes, which are scarce in the nature, are applied. We can learn how to obtain those isotopes and deliver them to the cancer cell, thanks to the transmutation process. Because after all, there's an industrial silicon transmutation. It is filled with neutrons which remove all the impurities. Yes, it's a mechanical treatment, but it's still a transformation, and nowadays we can easily apply the technology available to us and start implementing such projects in order to obtain specific chemical elements and isotopes through the process of transmutation. And first of all, we'll need reliable analytics, high-quality equipment for, separation purposes. Modern equipment is also crucial for the processing of the melts obtained. So basically, this kind of equipment already exists, and you just need to be competent enough in order to be able to use it. So for that matter, we need specialists who are willing to learn what has already been established. And if you know the parameters of the process, you can always choose frequencies, energy, because these processes take place within a certain setting, and it is known to be a specific density of the substance in the reactor. So there's a lot of work to be done, and people who are willing to finance these projects, they should be patient, because obviously it's going to take quite a bit of time, so there's not much money in it, so it's a lot more like a charity. And well, it's science after all, it's unpredictable. It's kind of a fun process, but it takes a strong will and patience and dedication. And how long do you think the scientific elite will keep on claiming that transmutation is impossible? When can we clearly see the evidence that everything has already been proven and shown? I've been doing this for the past 50 years. Before I used to think that everyone in 20 years' time will listen and understand. 15 years have passed, and there's nothing. I should say that in geology, people have already begun to listen. But there are certain conditions, however. The difficulty of the genre, so to speak, is that you must be able to understand where it all comes from. And the reason why they don't accept that is because there's an acute differentiation of sciences, physical sciences in particular. And then there's this physical snobbery. Physicists like to pretend that they know and understand everything. And the natural sciences are much richer, they give more food for thought. But they only know one thing, that is how to look straight. And this mindset doesn't let them to take a look at things from a different perspective. There were naturalists, knowledgeable people in several scientific disciplines, and then everything moved forward. As soon as differentiation occurred, and I know it from Dubna, high-energy physicists and elementary particle physicists don't understand each other. As we say in Russia, push comes to shove. When a trouble will come knocking on the door, in technological terms, let's say, only then they'll start searching for those rare chemical elements, because right now there's no necessity for it.
Приезжали даже из Сарова ребята смотреть. Но мне не повезло, а может и повезло. Перед тем, как им приехать, у меня сгорел трансформатор. Я не мог им все показать. Говорю, ну нет, это мало, ну что там. И уехали.